Let's take a look at solving some rational equations that require us to do just a little bit of extra work to factor the denominators, or to be able to see what our LCD is going to need to be. So today we're going to work on 4 examples. And so your first example is the equation 1 over x squared minus 5x, and that's going to equal x plus 7 over x minus 1. Now, as you can see, the denominator from the first fraction here has 2 terms, so we're going to need to factor that denominator to see what the individual factors are going to be for our LCD. And so this has a common factor of x. And so this denominator, instead of being x squared minus 5x, is really the product of a monomial x and a binomial x minus 5. And if I look at this denominator, which is got the most factors, that denominator, I need to make sure I have both factors in my LCD. So I need a factor of x and a factor of x minus 5. And if I go and I look at the other denominators that I have, the other denominator needs an x, but it's already present in my LCD. So I don't need anything extra in my LCD. This larger denominator covers everything. So my extraneous solutions now, I have 2. From the first factor, x is not allowed to be 0. And from this binomial factor, x is also not allowed to be a positive 5. So as long as I don't get those 2 values in my solution, I'm set. My solution is going to work. So now I need to multiply every term by that LCD. So at first, we're going to do this kind of the longer way at first, and then I'm going to try to shortcut it down a bit so we're not writing nearly as much. So really what it's telling us is that we need to multiply every term by this x times x minus 5. So every term we need to fraction bust, so that way I can cancel out the x's and the x minus 5, and I'm just left with the numerator of a 1. And then in the other fraction, when this x cancels with that x, now I have an issue. I need to multiply x plus 7 times x minus 5. And so what I'm going to do is over here off to the side, I'm going to do some side work to multiply those 2 binomials. And this is going to happen sometimes when you have more than one term in the numerator and you've got binomial factors when you're fraction busting. So I'm going to kind of take my time here and use my area box. And I can see that this x plus 7 times x minus 5 is the same as x squared plus 2x minus 35. So you are going to need to use a lot of your factoring skills when fraction busting. And now when I look at this last one, I need to take -1 and distribute that to break up the parentheses. But I'm going to attach the x to the -1. So I have a negative x squared plus 5x. And so now I'm going to combine some like terms here. Notice that the x squared and the negative x squared cancel out. So this is not going to be solving a quadratic. I'm going to be solving a linear. And since I'm solving a linear, I'm going to want to move this plus 35 to the other side, or sorry, this minus 35 to the other side by adding it. Okay. And so on the left side, I'm going to get 36 equals, and I'm going to combine my x terms on this side, and then I'm going to divide. Now, 7 does not go into 36 evenly, so we're just going to leave it alone. And as long as it's a simplified fraction, I don't have to do anything extra. And again, just double check that that's not one of your extraneous solutions, and you're good to go. That is your solution. That would make this original equation true. Even though it's a fraction and the fraction doesn't look like it makes much sense, it still works. We're not going to have to check it. We're just going to assume that we did our algebra skills correctly. So those are the steps that we discussed in a previous set of notes, a previous video. We're going to want to factor our denominators, find our LCD and our extraneous solutions, fraction bust, and then solve. So let's look at a few more. This time we're going to look at the fraction x over x plus 3 minus 4 over x minus 2. And that's going to be equal to a negative 5x squared over x squared plus x minus 6. So again, it's always a good idea to look at all of your denominators and make sure that they are all factored. Right. This is a binomial factor, and so is this. So I need to just verify. I want to know if this trinomial is the product of these two. So I'm going to factor this. So again, I'm looking for the product of two numbers that give me a negative 6, add up to be a positive 1, and plus 3 and minus 2 are going to do that. So again, this larger denominator, the one that has more factors, actually had the two factors I needed that were also present in the other two fractions. So my LCD is going to be that larger denominator. So again, x is not allowed to be negative 3 or positive 2. So what I noticed on the last example is that writing out those two factors sometimes can be a little bit, make it a little bit long. So what we're going to do is we're going to look at the pattern. Every time we multiply our fraction by the LCD, the current denominator gets canceled with one of the factors, and whatever the other factors that are left are what gets multiplied. All right, so let's look at that. That means that if I were to take this fraction right here, right, and I'm normally going to multiply by those two factors, one of them is always going to cancel. And so really what I'm doing is I'm multiplying the numerator times the factor that's not in my denominator. And so in the second example, or sorry, the third example, I'm going to start shortcutting that a bit, because I start seeing a pattern here of a factor that is going to cancel and a factor that is still going to be left. And I don't like having to write all of this every time. And so I will shortcut this in our next example. But I just wanted to kind of give you a heads up, a little bit of an idea of what I'm going to be doing. So notice that one's going to cancel. And again, I like to be able to look at that because really it's seeing, if I just kind of look over here, I'm going to be multiplying the numerator by the factor that would still be left when I canceled. And I'm going to do that now also. So I'm going to take this x and distribute. And I get x squared minus 2x. And then in the next fraction, the x minus 2 cancels. Again, if I look at my LCD, I'm going to be canceling out one of the factors, and I'm multiplying the numerator by the one that's left. And that's going to be a minus 4x minus 12. And now on this last fraction, all of the denominators cancel. So that's like me just saying, okay, I'm not going to be multiplying times anything. The numerator will stay the numerator. And now I will have a quadratic. So I'm going to move this negative 5x squared over and combine it to make a 6x squared minus 6x minus 12 equals 0. And now I need to factor this, and when we're factoring, we always want to look at the factors first and take out a GCF. So I'm going to factor out the 6 that's common to all of these, because that will make this trinomial on the inside a lot easier to factor. Because now I'm looking for the product of two numbers that give me -2 and add up to be -1. So I'm going to use -2 and +1. Now remember, when you solve this, because this is just a constant, 6 is never going to be equal to 0. So that's not part of the answer. The 6 is just a common factor as a common constant, and so I'm not going to have a solution for the 6. I will have answers, though, or solutions, when I check when are these two values going to be 0. So that's going to happen when x is a +2 and a -1. So again, before you box these answers, go back over here and check. The values that were not allowed were -3 and +2. And I came up with one of those values, which means that I'm not allowed to use that value in my final answer. If I were to plug that back into my equation, I'm going to get a 0 in 2 of the denominators. So that means the only answer I have is when x equals -1.